Okay, the algebra of functions, we have the sum, difference, product, and quotient of functions. It says let f and g be two functions. We can write the sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f over g, are functions whose domains are the set of all real numbers common to the domains of f and g. Okay, so if we look at these, if we want to find the sum of two functions, then we just add those functions together. Difference, we subtract. Product, you multiply. Quotient, you divide, provided that the function you're dividing by is not 0, because that would make it undefined. Let's look at the example. You're given two functions, f of x equals 2x minus 1, and g of x equals x squared plus x minus 2. Find the following and determine the domain for each function. Okay, so I have first f plus g. That means I just want to take f of x plus g of x. So f of x is 2x minus 1, and g of x is x squared plus x minus 2. I'm just going to add these two together. Combine like terms, so that would be x squared plus 3x minus 3. Okay, that would be the value of f plus g of x. Okay, then it says to find the domain for this function. Okay, are there any restrictions here? Okay, we don't have a fraction and we don't have an even root. So my domain would be all real numbers. Okay, on B, we're finding f minus g. So that would be f of x minus g of x. So f of x is 2x minus 1 minus g of x. Notice I put it in parentheses because when you subtract, you have to change the sign of every term. So I would have 2x minus 1 minus x squared minus x plus 2. And then combine like terms, which would equal negative x squared plus x plus 1. Okay, so that's the difference of the functions. Again, there's no restriction on your domain. So it's negative infinity to positive infinity. Okay, f times g of x would just equal f of x times g of x. So I have f of x is 2x minus 1. G of x is x squared plus x minus 2. And I'm going to multiply the two functions together. So first I'm going to distribute the 2x. That's going to give you 2x cubed plus 2x squared minus 4x. And then I distribute the negative 1, which would be negative x squared, negative x plus 2. Combine like terms, 2x cubed plus x squared minus 5x plus 2. Again, no restrictions. We don't have any fractions, and we don't have any square roots. So the domain is all real numbers. Okay? F over g of x means that we're going to divide our functions f of x over g of x. So I would have 2x minus 1 over x squared plus x minus 2. I can't divide any further. Okay, so that would be my new function that I'm writing. But I do have some restrictions on the domain. Okay, remember we do not want the denominator to be 0. So I would have to take the denominator, not equal to 0, factor. So that's going to be x plus 2 and x minus 1, not equal 0. So this means x plus 2 and x minus 1 not equal to 0. So x cannot equal negative 2 and x cannot equal positive 1. So as far as the domain, I'm going to write it over here. we would say the domain would be from negative infinity to negative 2, union negative 2 to 1, union 1 to positive infinity. So we want to skip over negative 2 and skip over positive 1. Okay, and then our next example gives you two different functions. It says find f plus g of x. So if I want to just add these functions together, f plus g of x would equal the square root of x plus 3 plus the square root of x minus 2. Now I can't go any further, can't add any like terms because these are all under the square root. So that would be f plus g. And then find the domain. Okay, I have to find the restrictions for each part of these. So the first would be that x plus 3 has to be greater than or equal to 0. So that means x is greater than or equal to negative 3. And also for the second part, x minus 2 greater than or equal to 0. So x would have to be greater than or equal to 2. So I have two parts of my domain that I have to look at. Greater than or equal to negative 3 or greater than or equal to 2. So what would be the intersection of these two sets would be greater than 2. So my domain would have to be from 2 to positive infinity because that would be the intersection of those two sets.